Okay, today our main learning target on this flex day is that you can prove lines are parallel using different angle pairs. If you recall yesterday, what we have done in class is we were given parallel lines and we came up with many different angles, congruent or supplementary. So really what we're doing is the converse. So this first one says, if two lines in a transversal form corresponding angles congruent, then the two lines are parallel. So in other words, in this case, we are given angle 1 is congruent to angle 2, and therefore, and I'm just going to use this symbol here, then we're allowed to state that L is parallel to M. And just like with some of our other things, we're going to have some abbreviations. In this case, we'll abbreviate this as converse of corresponding angles. Now notice this is a postulate, so this is something that I can't actually prove. We're just going to accept it to be true. All the ones after this, if you notice, are theorems, which means we can prove them, and in some cases we are going to prove them. So the next one is the converse of alternate interior angle theorem. So it says if angle 1 and angle 3 are congruent, then again the lines are parallel. So again, angle 1 is congruent to angle 3. Then we're allowed to state that J is parallel to K. And again, this is converse of alternate interior angles. And we're not going to stress the fact that they're postulates or theorem, I'm just trying to point that out. So in this case, we actually can prove this particular theorem. And again, remember, we're slowly working on proofs. Our last unit, we focused on algebraic ones with a little bit of geometric. We're going to hit some more geometric ones as well. So in number 1, we're given angle 1 is congruent to angle 2. So our reason is given. Our second statement that angle 1 is congruent to angle 3, if you remember, those are vertical, and we know vertical angles are congruent. And then finally, we can put angle 3 is congruent to angle 2. Now we got to go think about what property allows us to do that. Well, if you notice, 1 is congruent to 2, 1 is also congruent to 3, so we kind of have that go between in between here, and that is called the transitive property of, in this case, congruence. And finally, why is line L parallel to line M? Well, if you take a look at angle 3 and angle 2, we're actually using this corresponding angles postulate, which said if these two angles are congruent, then the lines are parallel. So this is converse of corresponding angles. All right, from that we then have 3 additional theorems, and again, we're not going to go through and prove necessarily all of them. We might through the course of the unit, but for today we're just going to stick with that one individual proof. So the next one says the converse of the alternate exterior angle theorem. So if you look, you've been given angle 4 is congruent to angle 5, which are exteriors. So again, we have angle 4 is congruent to angle 5, then line J is parallel to line K. And if you think about a basic proof for that, similar to the one that we did above, we could prove that 4 is congruent to this angle here because vertical angles are congruent, which means that, and we also know that these two are congruent because they're corresponding. So again, transitive would allow us to prove that angle 4 is congruent to angle 5. Next one, converse of same side interior angle theorem. Now remember, if you look at these are not congruent. Angle 1 in this case is acute, angle 2 is obtuse, so they cannot be congruent, which makes sense in here why it says they have to be supplementary. So in other words, in this case we have angle 1 and angle 2 are supplements. Then again, we can prove that J is parallel to K. All right, and then same thing on this last one. We've got angle 1 and angle 2 again are exterior and they are supplements. So again, we would have angle 1 and angle 2 are supplements. Then we know J is parallel to K. And if you think about this one, we could state that these are vertical, and these are the same side interior, which eventually proves that these lines are parallel as well. And as I said, for today, we're not going to focus on that. We'll be getting into some more of those proofs later on. All right, so let's go take a look at some applications in this case. So flip on to the back side of your notes. Okay, so in this case it says which lines, if any, must be parallel from the given information. Now, what I'm going to do is I'm going to go and grab a marker and I'm going to mark off, or maybe a highlighter, we'll see which one pops up best. The angles that I've been given are congruent. That way sometimes it helps the parallel lines pop out a little bit more. So angle 1 I see is formed by this line and this line here, and angle 2 is formed by this line and this line here. So once you highlight that, it might be a little bit easier to see visually which lines are we actually going to be able to prove are parallel. And it's these two pair right here that are popping out. And I'm having a hard time seeing what this one is. I'm going to label this, let me see, LM. That looks like an F. I don't know. I'm going to label this to be an N. So the lines that are parallel is we have N is parallel to L. Actually, I said that was an F. And these two right here, if you think back from your list, first of all, they are both on the inside of those parallel lines and opposite sides of the transversal. So those are alternate interior. And remember, it's the converse. So we're going to put converse of alternate interior angles, which says again, if the angles are congruent, then I know the lines are parallel. All right, let's move on to the next set. We have angle 3. So again, I'm going to mark off. Angle 3 is formed by this line and this line. Angle 4 is formed by that line and this line right here. So again, once you do that, hopefully you can notice the lines that are parallel. So it's L is parallel to M. If you take a look at angle 3 and angle 4, they're on the same side of the transversal and they're both above that parallel line. So they're in the same corresponding spot. So this is converse of corresponding angles. All right, the next one, 7 and 8. So let me take a look. We've got 7 is here and 8 is right here. Well, both of these are on the inside, but they're on the same side of the transversal. So those are actually same side, but in that case they have to be supplementary. So in this case, there is none or not enough information. Let's go look at the last one, 5 and 6. So again, 6 is formed by this line and this one. 5 is formed by this line and that one. In this case, they're supplementary, and they are both on the inside of those parallel lines on the same side of the transversal. So first of all, we have L is parallel to M, and this is converse of same side interior. Okay, let's go on to the next one. In this case, it says find the value of x that makes J and K parallel. Well, if you take a look at those angles, they are both above the transversal and they are on the inside. So this is the case that they would be supplementary. So in other words, x plus 4x has to equal 180. So we're just going to set up an equation and solve. 5 goes in there. 36 times, I believe, and all they want to know is the value of x, so we're done. If you look at B, these are interior and they are on opposite sides, so that means, and I'm just going to put this down here just to reinforce the vocabulary, these are same side interior angles. Okay, down here, these are alternate interior angles. We know alternate interior angles have to be congruent. So we are going to set 2x plus 20 equal to 3x. We're going to solve. So I'm going to subtract that 2x, and I end up with, again, x is equal to 20, and that's all they're looking for. Okay, similar on these last two. Again, we're just trying to apply those theorems from above. So the first thing I'm noticing, and again, I'm going to highlight these. I have this angle measure here, and I have this angle measure here. So when you highlight those two are on the inside, on the same side of the transversal. So those have to be supplementary, which means they have to add up to 180 degrees. My 40s cancel out. We're left with 2x is equal to 180. So eventually x is equal to 90. So if I know x is equal to 90, that means this measure right here is 130. Now let me just kind of re-pull out the picture. This is 130. I'm looking for angle y. Notice these are on the same side of the transversal, but on the inside. So I'm going to set up the second equation. These angles actually have to be supplements. And we end up with y is equal to 50. So again, just vocab. Same side interior, and up here, same thing. They were same side interior. Okay, let's go take a look at that last example. All right, so the first thing I'm noticing here is this guy right here. These angles would be corresponding, which means x is equal to 90 degrees. And again, they're corresponding. Okay, if you kind of turn your paper this way, and let me highlight some lines for you here, I see this angle here that I have information on is formed by this line and this line. This angle again is formed by this line and this line. So if you notice, both of these are inside the parallel lines on the same side of the transversal. So again, that means they are supplementary. So let's go set up that equation. So in other words, y minus 18 plus y plus 12 has to equal 180 degrees. Let's combine the like terms, and then you have an algebra 1 equation to solve. And we end up with y is equal to 93. So we've got the 90 here, the 93 here, so this angle in here is 93 degrees. Let's try that angle is not, but y is. So this angle is 93 minus 18, which ends up being 65. Let me just double check my math, and actually it's at 75. So finally, if this is 75, these two have to add up to 90 degrees, so I'm going to set up one last equation. I have 75 plus that z has to give me 90 degrees. I'm going to subtract, and eventually I get z is equal to 15. Okay, so just make sure you've got all of your notes completed so that way we can mark you as present tomorrow. You now have the next assignment, which if you have Murphy, we are on day 3. And there's also a small Canvas quiz that you want to do that goes along with that assignment as well. If you have any questions, feel free to send us a Canvas message. Thanks.